What is creep and fatigue failure in polymers? Imagine a plastic bottle left in the sun for years. Over time, it might slowly change shape or even crack without any sudden force. That slow change is called creep. Now think about a rubber been stretched repeatedly. After many cycles, it might snap suddenly. That is fatigue failure. Both are ways polymers can break down, but they happen differently. Creep happens when a polymer is under a steady load for a long time. Even if the force is small, the material slowly stretches or deforms. This is because the polymer chains inside the material move or slide past each other over time. Elevated temperatures make creep happen faster because the chains become more mobile. If the deformation keeps going, the part can become permanently misshapen or even break. Fatigue failure is different. It occurs when a polymer is subjected to repeated stresses that go up and down, like bending or stretching over and over. Each cycle causes tiny cracks to form. These cracks grow gradually, even if the stress in each cycle is less than what would normally break the material. After enough cycles, the cracks become big enough to cause sudden failure. Fatigue is common in parts that move or bend repeatedly, like gears or flexible tubing. Understanding these failure modes is important for designing long-lasting polymer parts. Engineers perform tests to see how materials behave under constant load or repeated stress. Creep tests involve applying a steady force and measuring how much the material deforms over time. Fatigue tests cycle a load on the material repeatedly to see when cracks form and grow. These tests help predict how long a polymer component will last in real-world use. In practical terms, if a polymer component is used in a hot environment or under a constant load, creep could cause it to lose its shape or fail slowly. If it is part of a machine that moves repeatedly, fatigue could cause sudden cracks or breaks. Choosing the right polymer and designing components with these failure modes in mind helps ensure safety and durability. Both creep and fatigue happen below the maximum stress a polymer can handle. Creep is mainly about molecular chains slowly sliding past each other, leading to flow-like deformation. Fatigue involves microscopic cracks that grow with each cycle, eventually causing the material to break. Recognizing these differences helps engineers select the best materials for specific applications. So, in the end, understanding how polymers deform and fail under different conditions helps us make better, longer-lasting products. Whether it is a plastic part in a car or a medical device, knowing about creep and fatigue is key to keeping things working safely over time.